Bright Tuty. Every student matters.
Now let us see a few questions based on how to use sonar with the help of the values. Right? A ship sends out ultrasound that returns from the seabed and is detected after 3.42 second. Now if the speed of ultrasound through sea water is 1531 meter per second. Now we are taking the speed, right, 1531. Reason for that is basically the speed varies in water depending upon lot many factors that we have already studied. So what is the distance of the seabed from the ship? Let us see what exactly is given to us in the question. First of all, the time taken denoted by small t is given to be 3.42 second. The speed of ultrasonic waves denoted by small v is given to be 1531 meter per second. We have to calculate the distance, that is s, right, from the ship. Now if I am talking about this particular ship and this is the seabed, so the distance travelled, as we have earlier studied, it will be both sides. So I will take one side distance to be d and the total distance travelled basically is so called twice of d. So I will put up the formula. Distance is calculated by the product of velocity and time. Distance I have just put it to be 2d because it is twice and I need to calculate the one way. So d is equal to product of speed and time divided by 2. Now the velocity or the speed of sound wave is 1531 meter per second. Time given is 3.42 second divided by 2. So when I will calculate it, it will come out to be 5236 divided by 2, which in turn will be 2618 meter. So the distance of the seabed from the ship is 2618 meter. Clear? Let us take another question. A submarine emits a sonar pulse which returns from an underwater cliff in 1.02 second. Once again, the time is given to us to be 1.02 second. If the speed of sound in salt water, the speed is given to us v is equal to 1531 meter per second. How far is the cliff? Right? We have to calculate the distance of the cliff. Once again, the distance travelled we have to calculate, which will be equal to 2d, let us say, d being the one side distance. Again putting up the values, distance, that is 2d, will be equal to product of velocity and time. D will be equal to v by t into 2. Putting the values, I will get 1531 into 1.02 divided by 2, removing the decimal, multiplying it with, I will get this value. After calculation, it will come out to be 780.81 meter. So this is the distance of the cliff, right. So this is how we calculate the distance of the seabed or anything in sea using the sonar, right. Fine. A sound wave travels at a speed of 339 meter per second. So the speed of sound is given to me to be 339 meter per second. If its wavelength is 1.5 centimeter, the wavelength is given to me to be 1.5 centimeter. What does it mean? That I need to so called convert it into meters, right? So how I am going to convert it into meters? Just divide it with 100 and I will get 0.015 meter. This will be the wavelength. Alright. We have to calculate the frequency of the wave. So what we are required to calculate is, we will be calculating the frequency. Now I know the formula, that frequency is calculated by the formula speed upon wavelength. From where? Because of wave equation. So putting the values, the speed is given to be 339 meter per second and the wavelength is 0.15 meter, right? Cutting it off, I calculate it and the value which comes out to be 22,600 hertz, right? So this will be the frequency. Now one important thing is, will it be audible? Audible to us. We know that our frequency ranges from 20 hertz to 20,000 hertz, but it is more than that of 20,000. It is 22,600 hertz. So this sound is not audible to us. Why? Giving the reason, because we can only hear the sounds up to frequency of 20,000 hertz on the upper side. Clear? Now let us see next question. A sonar device on a submarine sends out a signal and receives an echo in 5 seconds, right? So the time given to us is 5 seconds. Calculate the speed of sound in water. We have to calculate the speed of sound in water. This is what is not given to us. We need to calculate. If the distance of the object from the submarine is 3625 meter, the distance is given to be 3625 meter, right? We need to calculate the speed. We know the formula for speed. Speed is simply calculated by the formula distance upon time. Now a very important thing that we need to remember in this particular question is, the values are simply given, distance is given, time is given, but when we are talking about sonar, we are talking about echo. That means that the sound is first of all reflected from a surface and then reaching our ears. So if it is reflecting through a surface, then in that case the distance travelled will be doubled to what exactly is given. So the distance of the object and the ship, if one side it is given to be 3625 meters, it has to, the sound wave has to go one way. After striking, if reflected, it has to come back reaching the same, covering the same path. So the distance will be doubled. So if it is 3625 one side, we will take it to be double of it. Why? Have you understood? Good. And the time given is to be 5 seconds. Simply I will just multiply and I will cancel out. The value after calculation will be 1450 meter per second. So this will be the speed of sound in water. Alright. So these were the few applications of ultrasound. We have seen that ultrasound is used in wide fields, very widely it is used, whether it is used to detect the flaws in the metal blocks, or it may be used to investigate the human body. It is also used to investigate the development of fetus. It is used for investigating the working of heart. It is used to break the kidney stones. It is used by bats in order to locate their prey, using the technique of echolocation, and it is used in sonar. This is very, very important. Please try to relate and learn it thoroughly. It is the important topic that you have done and studied just now. Fine. Thank you so much for watching.